All right, so now we're going to go through nomenclature of polyatomics. So these can be used for both type 1 and type 2 naming systems. So poly means more than one atom. So all the ones that we've previously been doing, those are all what we call monoatomic because they're all just singular elements like nickel and chlorine. These are going to include polyatomics. So if you look all the way on the last page of the notes, you'll see a list of all of the different polyatomics. So for example, acetate is C2H3O2 and it has a -1 charge. The charge isn't going to affect the name, it just helps us to write the formula, which we'll go through later. The main thing with polyatomics is that they keep their name. So when we're naming our monoatomics, the second element changed to IDE. Here, if we were using acetate, we would just write sodium acetate, so it keeps its name. So what we're going to do is we're going to go through a couple examples. So again, you have to look at the naming system you're going to use. So remember, type 1 have no Roman numerals, where type 2 have Roman numerals. So you need to figure out, well, am I going to be using Roman numerals or not? So we want to look at sodium. So if you look at sodium on the periodic table, you say, oh, it's in group 1. Okay, group 1, I know the charge is +1, so there is no Roman numeral. So I would just write this as sodium, and then I would look up NO3 on that list. It is also on the back of your periodic table. So if you flip that green periodic table over, you'll see that there's a list on top, and those are organized a little differently. So either or is fine, but you go down here and we find NO3, which NO3 is going to be right here. So I look at the name and that is nitrate. So this is going to be named as sodium nitrate. The next one we have Ca. Okay, that's in group 2 on the periodic table. So again, this is type 1. So no Roman numerals. So I would name this as calcium. And then I look up SO4. So I go on my polyatomic list, find SO4. Okay, SO4, again, that charge doesn't do anything to the name, so I would write it as calcium sulfate. So you guys can do the next. I will write the answer, but this one will end up being sodium phosphates. Here I want to go through FeOH because this one is going to be, so both of these are actually going to be type 2, meaning that we need to add the Roman numeral. So this one will be iron, and then we need to figure out what the Roman numeral and the polyatomic is. So if I go and look on my sheet, I have OH minus. So I have to find OH minus on my list. And again, you'll learn them. So OH minus is hydroxide. But I need to pay attention this time to what the charge is so I can find the Roman numeral. So hydroxide is OH minus 1. So I'm just going to write that down to help me. So I have OH minus 1. Well, if I look, and again, so it's Roman numeral, iron something hydroxide. I need to figure out the Roman numeral. And again, the Roman numeral is the charge of the metal. Well, in this compound, I have one OH and one iron. Well, if hydroxide has a -1 charge, that means the iron must be +1 so that they equal to 0. So that tells me iron has a +1 charge. Where this one, I'm going to look up SO4, which we already looked up, and we know that that's sulfate. So if I look on the periodic table, sulfate is SO4, and you'll see that there's a -2 charge. So I know it's iron something sulfate. Well, if sulfate is -2, in order to cancel that out, iron must be +2. So it would be iron 2 sulfate. Now this is where it gets a little tricky when we're going from the name to the formula. The thing I want to make a note of is for example, sulfate, which is what we just did. This is SO4 minus 2. This SO4 is because we have, it is our tetrahedral molecule. So it is one thing. So you cannot change that 4. Like SO4 is its thing. There are 4 oxygens bonded to that sulfur. So for example, for this one, I have Na is +1. SO4 has a -2. We are only, when we're looking at the formula, going to pay attention to the charges. The subscripts cannot change because this sulfur needs 4 oxygens bonded to it. So now I just follow the same idea I did with the previous ionic compounds. So I'm going to now do Na2 because we, remember, get rid of the positive and negative and you crisscross. So it's Na2SO4. And that would be my formula. So the next one we're going to do is we have magnesium. Magnesium is Mg+2. Hydroxide. So you'll notice like this one ends in 8. That's our clue that we're talking about a polyatomic. Hydroxide ends in IDE like our other elements, but this one's actually a polyatomic. So you kind of just got to remember that IDE means that it is a polyatomic for hydroxide. So normally, again, like if we did sulfide, that's S-2. So usually IDE means an element or a monoatomic, but hydroxide's one of the exceptions. We've done this one earlier, so it's OH-1. So this is where we need to be careful because this OH is telling us that our molecule itself is O bonded to H. So that's one thing. So when we crisscross, we need 2 of these. So we need to put it in parentheses to represent that that is one molecule and that polyatomic we want 2 of. If we didn't put that in parentheses, it would look like this. That's saying that we had 2 hydrogens and only 1 oxygen, but I want 2 of those polyatomic ions. So this is not correct. We need that polyatomic in parentheses. All right, the next one we have is ammonium phosphate. So ammonium is not an element. It's actually a polyatomic. It's one of our few metal polyatomics. We know it's a metal because if you look on your list, it's NH4 plus 1. So again, it is on your list. If you look on the back of the periodic table, it's there or down below. And again, because it's positive, we know that it's a metal. So I know NH4 is +1. Phosphate, I can go and look on my list. So I'm going to find phosphate. It's right here. So that's PO4 -3. All right. So again, ionic compounds want to be neutral. So you can either use the crisscross method or just think about it logically. Well, if PO4 is -3, in order to cancel that out, we need to have 3 NH4s. But remember, NH4 is a tetrahedral molecule. So that is one thing. We can't change subscripts. So what we're going to do is I'm going to write NH4. Well, I can't add the 3 there because then it looks like I have 43 hydrogens. So what I do is I use my parentheses, and that 3 goes down there. So now it's saying I have 3 NH4 ions, and then we have PO4. I only want 1 of them. So I am not going to put parentheses around that. It is just going to be NH4 parentheses 3 and then PO4. And if I were to add those charges up, it would give me +3 and -3, so it'd add to 0. And then we'll do number 4 together, and you guys can try 5. So lead, we notice we have that Roman numeral. So just a reminder, that Roman numeral, all it does is tell me the charge is +2. So PB's plus 2. Sulfate, we've already done up here, is SO4 minus 2. Same rules apply with charges canceling out. So if PB's plus 2 and sulfate's negative 2, then we only need one of those. So it'd be PbSO4 because the 2's would simplify to 1 and 1. So we only need one PB and one SO4. And no parentheses because we only need one of the SO4s. So you only add parentheses if you are adding more than one polyatomic.